Section 4 of A deals with operations of rational expressions. These notes on Section A start with interval notation on page 10. If you cannot figure out how to do interval notation, contact your teacher. It should have been covered in class. These are in the notes. You can check some videos on my channel, which you should have joined, that will be labeled interval notation that I created for Algebra 2 Honors this spring while we were in captivity in our homes. So we're going to start out with domain. This is a very important idea, and people have difficulty with this, and there's simply no reason for it. Domain is all real numbers. Always, that's where you start out. Oh, I'm all real numbers. But, if a number makes the denominator 0, then I'm not in the domain. And if I have a radical, and the radicand has an even index, that's a root, like a square root, fourth root, sixth root, eighth root. The radicand, that is the stuff under the radical symbol, cannot be negative. Okay, some examples. What is the domain of x squared plus 5x minus 1? I say all real numbers to start with because there is no denominator, is no radical, so your answer is reals, and yes, you can abbreviate it that way, or you can use interval notation. This next one, we know the domain is all real numbers, except we have a denominator. Does anything make the denominator equal to 0? -2 does. So we could write x is not equal to -2, or we could use interval notation. Example 3. The domain is all real numbers, except what makes the denominator 0? What makes the denominator 0? Well, I have to factor it, and I find out both -3 and 0 must be removed from the domain, so it's all real numbers, but -3 and 0, and I can write it either way. Now I have a radical. What makes a radical, what's the domain? Well, it's all real numbers, but I see, it's an even index. It's a square root. So the domain is, I cannot be negative. How do I write not negative, greater than or equal to 0? So I could say the domain is all real numbers greater than or equal to 2 in words, or I could write x is greater than or equal to 2, or I could use interval notation. Another radical, and again an even index. Notice it's a fourth root. So again, the radicand, the 5 minus x, must be not negative. And so I have 5 minus x is greater than or equal to 0, and solving, note I have to reverse the inequality because I'm dividing both sides by -1. So my domain is all real numbers less than or equal to 5, or x is less than or equal to 5, or I can put it in interval notation. The next problem, well, not only do I have an even index, which means that because of the square root, but I also have a denominator, which means I cannot be negative or 0. So x plus 4 must be greater than 0. So x is greater than -4, and I can write it in either form. Now, part A, once we got past domain, I'm going to ask you to simplify simple fractional expression. Notice you're going to factor the numerator and denominator and reduce. So I went ahead and factored each. Pretty basic. You should be able to do that. We just reviewed factoring. And I reduced. And so here is my simplified expression. The next one. Again, I factor each term. The numerator is the only thing that factors. I can reduce only one set, and I end up with x plus 2. Here only the denominator factors. And now when I cancel, I need a 1 because I can't have blank over x minus 1. Technically, when I reduced here, it's a 1, but what's 1 times something? It's always the something. The next one, I go ahead and I factor the numerator. It's a common factor. The denominator, most of you would prefer to factor out the negative, even though you could see their opposites, and I get -x. Now I have to factor both There is no way around it. I see they share x minus 3. I reduce it, and my answer is x minus 5 over 6. But what is this in terms of domain? When we talk about domain, anything that makes the denominator 0 in the original expression is kicked out of the domain. So I don't say the domain is everything but 2. The domain's everything but 2 or negative 2, because 2 and negative 2 make this 0. What's the only thing that makes the denominator 0? Negative 2. So my domain is x is not negative 2. What makes this denominator 0? Well, 3 and 1. Therefore, even though it looks like only 1, once gone, always gone, so x cannot be 1 or 3. In this one, what's the only thing that makes the denominator equal to 0 is 12. And so my domain would be all real numbers but 12. In this one, what's the only thing that makes the denominator 0 is 3. So my domain is x is not equal to 3. Now, when we multiply rational expressions, we actually factor the numerator and denominator, reduce, and then we rewrite the remaining factors into a single fractional expression. So given this, notice how I factored everything. You should be able to do the common factor and the easy trinomials. Now I color-coded so it's easier to follow the video of what I'm able to cancel. What am I able to reduce? Well, the x plus 3's are alike, the 4x's are alike, the x minus 1's are alike. So the only thing that's left in my problem that I can't cancel out is the x minus 2. Now, if you want, just give me a second. I forgot to take my lid off my marker. I could have gone through and said, look, they share 4x kills 4x, x plus 3 kills x plus 3, x minus 1 kills x minus 1. Oh, wow, x minus 2 is all that's standing. But what made the original denominators 0? Well, negative 3 and 1 here and 0. So what is actually the domain of this expression is not all real numbers, but the domain is x is not negative 3, 1, or 0. In this next one, I go ahead and I factored. And again, I color-coded to make our lives easy. But first, what would my domain be? Can't be 0, can't be negative 1, can't be negative 3/2. Now I'm ready to say, what do I get to cancel? Those get to cancel. This x kills that x. This x plus 1 kills that x plus 1. What's left are 2 and x minus 1. But we know the domain is not all real numbers. The domain is all real numbers, but the negative 3/2, the negative 1, and the 0. Another expression we're going to go ahead and factor. Notice this is x squared plus 9, not x minus 9. It doesn't factor. I factored everything. What makes the denominator 0? We're doing real numbers. This would be plus and minus 3i, so we're not going to deal with I, guys. So I find 3 and negative 5. 3 and negative 5 are not going to be in my domain. So I can go ahead and reduce, and the x minus 3 cancels the x minus 3, and that's it. Now notice, I put the negative side dead even with the division bar. That means negative times the entire numerator. I could have rewritten this expression. I could have written it as negative times x plus 3 in the numerator. That's a lousy looking negative sign. Or I could have written the numerator as negative x, negative 3. All of these are legal. You'll see this in the book sometimes, but you see this a lot of times, and they love this, especially on SAT testing, folks. So now for the last example, I have this. I went ahead and I factored everything. Again, I color-coded so you could see what I'm going to be able to reduce. Notice what makes the denominators 0, 5, -4, +4, and -2. So each one of those numbers is not in the domain, but let's see what's left standing when I cancel. The x plus 4 kills the x plus 4. The x minus 5 kills the x minus 5. X minus 4 kills x minus 4. And I'm simply left with something that looks like, oh, only -2 is not allowed. There is a rule in mathematics. Once gone, always gone. Please remember that. Once you kill it, you can't have it in the original answer. Now we want to divide rational expressions. So we're going to rewrite the divisions as multiplied by the reciprocal of the divisor. We'll factor the numerator and denominator, we'll reduce, and we'll write the remaining factors as a single expression. So here's the original problem. Notice my step 1 was simply to rewrite it. What most of you do is you don't do this as a single step. You just go ahead when you're rewriting this, you write it in factored form. When you're flipping it, you just write the factors of the denominator in the numerator and the factors of the numerator in the denominator. So this becomes step 1, step 2, and then step 3. Now, if I ask you what's the domain, here's what's tricky. What is the domain of the problem is what makes the original denominator 0 or 2 and 4. And what made this one 0 was 3. What else makes the final denominator 0 is 0. So not only did I kick out the 4 and I kick out the 2, but I also have to kick out the 0 when I'm talking about domain, because right up here, whatever makes these denominators 0 is not in the domain. When I rewrote it, whatever makes these denominators 0 is not in the domain. And as we see, I color-coded as best I could, so this cancels, those cancel, and I'm simply left with 2/3. But the domain is I could not have the numbers 0, 2, or 4. This next one drives people crazy because remember, this really means over 1 because everybody needs to have a denominator. So now I'm going to multiply by the reciprocal. Again, most people don't write this step. You go from here to there. I factored it. I used the reciprocal. Notice what makes the denominator 0 is 0 here. What makes the denominator 0 here is 1. So 0 and 1 are gone, and I reduce. The next one. Again, you see me going ahead, but I didn't bother to factor and read these because I noticed these two were exactly alike, and notice they cancel. And so if I don't ask the question domain, all I have to do is this, and I'm done. But what if I need to know the domain? Then I need to factor that denominator, and I see that, oh wow, 0 and plus or minus √2 were not allowed for that particular denominator. So this guy's domain would be all real numbers but 0 and plus or minus √2. For the final one, again, this step you could skip if you would like and go straight from here to here. But what makes these denominators 0? -3, and when this is factored, 0. Down here, what makes this 0? -3 and 5. So what have I kicked out? -3, 0, and 5. But again, we're just asking you to factor and reduce. I'm just trying to emphasize domain. And so again, my answer then is -x times x plus 2. Again, when you're doing domain, remember once gone, always gone. All right, we have a few more things to do in the other room. So let me move in, and we will continue with these kind of problems. So what happens when you want to add and subtract rational expressions? Well, the key is the game of what's missing. And what's missing is what teachers really do when they tell you, oh, we have distributed and multiplied, and now we've canceled. What's missing takes care of the canceling, and it's a pattern you need to know if you've not learned it. By the way, I have videos that I've set up for Algebra 2 where I've shown this in absolute detail. For those of you that are still confused, you can go look at those again. So I make sure each denominator has a denominator, and I insert a 1 if I need to. I rewrite the subtractions as additions as plus the opposite. I find the common denominator, factoring if necessary. I compare each denominator to each and to the common denominator and determine what's missing. I place what's missing with each denominator in the appropriate numerator. From each denominator, I meant to say, in the appropriate numerator. I place these results on top and the common denominator on the bottom. I simplify the numerator and factor and reduce if necessary. So notice the first one, I rewrote that as plus -2. My common denominator is x minus 4 times x plus 3. What's the first denominator missing? X plus 3. What's the second denominator missing? X minus 4. Now, you've been taught to come up here and multiply by x plus 3 over x plus 3 and x minus 4 over x minus 4. Seriously, folks, we need to get this pattern down because your algebraic skills have to be great. So, what is this denominator missing? The x plus 3. So, 3 gets x plus 3 because I'm going to write the common denominator already. I don't need to worry about saying, oh, if I don't put the x plus 3 here, I'll forget about it. No, my common denominator's there. What's this factor missing? X minus 4. So, what does -2 get? X minus 4. And now we distribute and we simplify. In reality, I don't do this extra step. I write this stuff up here. I would write 3x plus 9, -2x plus 8, saving space. You'll see it in my next problem. Next one, I rewrite it as plus the opposite and I factor. What's the common denominator? Technically, you're supposed to say, oh, gee, I have to do an x minus 1 times an x minus 1 here, and this guy needs an x minus 3 and x minus 3. Get over it. Your common denominator, what's this guy missing? X minus 1, so the numerator needs x minus 1. What's this one missing? X minus 3, so the numerator needs x minus 3. I provide it. Notice I show the distributing up above. I do the arithmetic. And since this is a teacher-made problem, as most of these stupid problems are, most of the time they will factor and reduce. Not so in your textbook, maybe 10 to 20% in a textbook. But I'm going to tell you right now, on the old ACT and some of the SAT tests, they're really out to get you on these factor problems where you can have them. Next one. Again, what am I going to do? Find the common denominator after I factored. What do I notice? This denominator needs an x plus 2, hence 4 is missing x plus 2. This one needs x plus 5, hence 3 is missing x plus 5. So I put them in, I distributed, I combined, excuse me, no, nothing factors and reduces. Typical, kind of like a textbook problem. Now, complex fractions. We need to find the common denominator of each denominator in the numerator and denominator. When there's not a denominator, insert a 1. Technically, you're to multiply each term in the numerator and denominator by this common denominator, then reduce. But what we're actually going to do is play what's missing. And after we've played what's missing, we'll take care of the reducing part, and then we'll factor and reduce the final expression. So here's the problem. I inserted the 1s. Yes, I must show that I'm multiplying by y over y, my common denominator. And so now what did I do? I play what's missing. What is 1 missing? Y. What is he missing? Nothing. If you feel better and you want to, you can always say, oh, he needs a times 1. Nobody will fault you for saying that. What does 1 need? It needs the y. What does y need? It needs nothing. And if it makes you feel better, you can put in times 1. And then you factor and reduce. Again, these are teacher-made problems, so they tend to usually factor and reduce. Next problem. Notice I need to write that as plus the opposite. I factored each. I circle the denominators. My common denominator is x times x plus 2. And now I play what's missing. Excuse me, my marker was drying out. And so, what is x missing? It's missing x plus 2. What's x plus 2 missing? It's missing the x. What is x times x plus 2 missing? It's missing nothing, so you could write a 1 or you don't have to write anything. And what's the x missing? It's missing the x plus 2. Now I went ahead and simplified the numerator, so 5x plus 10 minus 3x becomes 2x plus 10. I simplified the denominator, 3 plus x plus 2 becomes x plus 5. And shock, shock, it's a teacher-made problem, so it factors and reduces. Next problem. I see radicals. I don't get hysterical. I put in the over ones. I know I should have said plus a negative. It won't kill us because there's not any binomials present. When they're all monomials, it doesn't matter. My common denominator is square root x. What does square root x need? Another square root x. What does this square root x need? Nothing. It just becomes 1. What does this 3 root x need? A root x. Now, I'm not going to stop you from, oh, square root x times this is x, over 1 is x, and this times this is all the root x's cancel, and now it's minus 2. You want to do all that work. I won't stand in your way. But when you get into calculus class, no professor is ever going to do that. Next problem. Everybody has a denominator. I went ahead and circled and factored. I indicated that I'm multiplying by my common denominator. I'm going to play what's missing. Notice what's missing is written in purple, in green, and red down here. This is missing the x plus 2 and x minus 2. This is missing x and x plus 2. This is missing only x. So I went ahead and I multiplied and got x squared minus 4, which is 3x minus 12, 3x squared minus 12. This is 2x times that is going to give me 2x squared plus 4x. And I end up with this as my remaining answer. Yes, I set up another one that doesn't reduce. Now, we're going to rationalize two terms when two terms are present. And notice we're going to do it just like we did with numeric expressions. We're going to use the conjugate. So I use the conjugate. Now remember, inside a square root, that term is actually a parenthesis. I showed it. The old calculators, you used to have to put in a parenthesis. So we're going to still simplify the denominator as we did before. So notice that's 16 minus, and it's a binomial. I must have the parenthesis so I don't end up with 32 minus x, but negative x. I'll notice it's going to reduce. And so I have negative and I distribute. Now I created these that reduce because these are the ones that cause you issues. The ones that don't reduce don't cause you issues. So I'm only doing examples of troublesome problems. So again, I'm going to use the conjugate. Again, I distribute. Notice again, that's a binomial on the inside. So it has to have a parenthesis when I subtract. So it's not 50 minus x, but negative x. Again, I created it so it reduces. And we can leave the expression either way. If it's multiple choice, or if they say completely simplify and they don't want any products, just read the directions to see what's being asked. The last problem is an application of this. I'm throwing in a probability, a simple one. I want the area of the green section, and so I want the area of the green region over the total area. So I set up my areas, which is the area of the green over the total area. Notice the x plus 6's cancel, and now I make sure I have a common denominator, and I put that x plus 3 over 1, and now I multiply by 3 over 3. This guy needs nobody, and this guy needs 3, and so that would be the probability in expression terms. So again, this is stuff that you all just need to become familiar with being able to do and do well. I can't explain to you how much your higher level math courses that you take in college demand on your skills. And if you go into calculus in college, the professors will not review any algebra. They will just assume you're experts.